Okay, so welcome to the first show and tell of the year. We're doing a joint show and tell with the BCS Mid Wales and the BCS student chapter. So we've got a group of talkers, then we'll have a break for the showing and the pizzas, and then we'll have the rest of the talkers, and then we have a prize of a Raspberry Pi for the best voted tech shower or teller. So I will hand you over to Jim, who will then talk to you about Chromecast.
Chrome Bell.
Chrome Bell.
I don't like the drums. I started them by accident. More a demonstration of technology than anything else. You start the drums, the piece loses a bit of structure straight away. But what we got here is a glove with a 3-axis accelerometer there, so it knows how I'm waving my hand about. And touch pads on the fingers. So for example, if I'm holding my hand that way, I can change the chord I'm playing. If I hold it that way, I can change the mode I'm playing. So that's major. That's minor, relative minor to the major, if any of you know anything about music theory. And that'll be Dorian, because we like them ecclesiastic modes. Back to normal again. Turn off some of the instruments. It's a while since I wrote this, so it's hard for me to remember how to do it. And it'll turn off at the start of the next cycle. Turn on the filter. And with the filter on, the position of my hand sweeps the filter. Battery's going to come out any minute. There's also that webcam. And more sequences being triggered by that. This piece is a little monotonous because it was originally written for the Access All Areas event earlier this year. So it was designed to just have the crowd wandering around, triggering these elements while I control the whole piece through mucking about with the glove. It's called Chrome Bell because all of these sounds are bell sounds. Struck bells, Tibetan prayer bells, all synthesized, and even what a bell would sound like if you somehow managed to bow it. There. Before I run out of time, I'll stop.
Any questions for Jim?
Any technical questions or anything?
What are you doing on the camera? What are you watching for?
What I'm looking for is just spots to be hit. I'm using very, very simple motion detection. And if anything changes, the program I've written will detect the changes in certain spots and will fire off MIDI notes. There are about 4 or 5 programs running, and they're all communicating with each other through MIDI internally. I can watch several kinds of things.
Okay.
How do I watch this? I don't know.
Potential future applications, what will they be?
Art. Primarily, that's my interest. It took me about a fortnight to build the thing because I wanted to make music with it.
Okay.
But there are other possible applications. Control, for one thing. If you've got the 3-axis accelerometer, so you've got your pitch and roll. I did talk with Owen about the possibility of flying his quadcopter like that, which might be a more natural way than flying with a joystick. Because if you actually control the configuration of the quadcopter directly, you're removing one layer of abstraction. So it might be fun to look into that at some point. So, but also because it's cool. Why do we do anything? Okay. Thanks very much.
So next up, we have the Sailbot team to talk about their past, present, and future.
Sorry, I think the slide. Which one's the slide? far one.
This one
Yeah. I think.
should be a clicker.
Sorry? We're going to be angled this way.
Oh, right, yeah.
No, no, we can.
Okay, you ready?
No, I'm saying that one. Oh, that's Mike.
Yeah.
That's not going to work. There are 4 of us.
We all cuddle around it.
Just do this, yeah? Easy.
We can penguin huddle.
Yeah. Pass it back and forth.
Yeah, that's it. Just hold it close, should be fine.
Is that showing?
We can start the demolition procedure.
It's always okay.
It's language synthesis.
Okay.
Okay.
Yes.
So,
Right.
right away.
So, as many of you know, we are ABBA Sailbot. We're a group of students, plus Colin, who were founded in 2012. And since then, we've been to, I think, 6 competitions around the world, competing with, well, our 3 autonomous boats. We've got Derry, which we can see here, which will be available to see in the concourse later. We've got Kitty, which is a much bigger 2-meter long boat, which you'll see in a second, and Bob as well, which we'll explain as well. So this was the first year team, and this is a slightly more expanded team from last year. But the original team were all on their industrial years last year. Always goes well.
Presentation didn't go well.
Not recovered yet. That's okay.
Did you quality?
Nope, that's not right. No.
So this is our boat sailing.
This way you leave it off, it's not CDF is there.
Okay. Right. Louis.
Okay, so this is Dewey. This is a robot we first competed with during our first year. So yeah, so that's we worked on that for a year. We took that to Sailbot and so we took that to Boston, competed in a competition, and also took it to France to compete in another competition. Just what yeah, just like that.
So Bob for the boat in the middle. Bob is designed to be our long endurance boat. Unlike the other 2, which use largely pies to control them, uses a small Arduino, which uses way less power. And the end goal of it is to cross the Atlantic Ocean at some point.
And then there's also Kitty, which is the N. Kitty is a cat rig, hence the name Kitty. That's the boat we built here after doing, and it's quite a lot larger. And sadly, I spent too much time on the rudder, so the sail got a bit neglected. Hence, it doesn't sail very well.
We should be fixing that this year.
Yeah, so in terms of control system, as Jordan said, 2 of them are running on local pies, which allows for quite a flexible configuration of what we actually do on that. We have a lot of power and a lot of scope to essentially do whatever we want on board the control system, whereas Bob is quite a much more limited system.
Right.
So, do you want to talk?
Yes, I will. Good. So over the past 3 years, we've been out to various places around North America and Europe. We started off with Boston, with Derry in 2013. And then after that, we went to WRSC in northern France.
What's WRSC?
Yeah, WRSC is the World Robotic Sailing Championships. Every year it's held in somewhere around Europe. So originally it was, well, our first year, 2013, was held in France. Last year it was held in Galway and Ireland by HP. And then this year it was held in the Åland Islands, which is a remote part of Finland, in the Baltic somewhere. Then in 2014, we took Kitty, after spending the year working on its rudder, to San Francisco, which was a really interesting experience, actually, because quite a few of the competitions have ended up with, you show up with a half-working boat and you finish the competition with a mostly working boat. We also are very keen for helping the community, so we show up to beach labs, if that still happens, but when it did happen, we showed up, which was basically an opportunity for projects in the university to show off to the local community around our Brestbury. We've taken the boats to quite a few different pie jams. We've taken one to the London Pie Jam, Cambridge Pie Jam, Swansea Pie Jam, and McCuntler, which was our first one, which is just down the road, for anyone that doesn't know. We also take the boats a lot to Mark's Lake. Mark Neal is one of the lecturers here who kind of inspired the whole project, and he has a lake outside his house. So that's where we do our testing.
Right, so last year the group decided it'd be a cool way to get the new members interested in boats by holding a competition at the start of the year. I was a first year last year, so I competed in this first ever set. And basically what they did was they provided all the new people, they split them into groups and provided them with the basic components for building a tiny little boat out of bottles and doing the electronics themselves and stuff. They provided a really good entryway into learning the core logic behind sailing boats and putting electronics together. Really got everybody to come together really well. And we want to carry that forward this year, do it again, and take all the good things that worked and bring them forward, and the bad things that didn't, leave them behind. But it's a really good way to get new people interested and in-depth with the project really quickly.
Okay. Right, yes, that's me. So our plan for this year is going to be taking it to Sailbot, which is, we're taking one of the boats, probably Dowie, which is currently in the best state of working, and definitely will be by then, which is in Kingston, Ontario, which is going to be fun. So that's going to be hosted by Queen's University. We'll then be taking it to WRSC, and hopefully we'll also be taking Bob to either the Canary Islands or Norway. But as you can imagine, we're kind of pushing for the Canary Islands because weather. Then hopefully, if we get it working, we will be trying a Trans-Irish Sea crossing with Bob, which is the closest large body of water for testing, and there's a slight chance we will actually be able to follow it using, a full-size boat that we can be part of for the entire crossing.
And in case you're confused what island is, we have a handy diagram.
Yeah, Aberystwyth, Ireland.
So in terms of software running, so obviously we want people to come and get involved. So we're going to re-overview kind of what we're doing. So obviously we have on Dewey and Kitty, they share very similar code, very similar core structure. So we can show code between the two. Because obviously electronics are across. So always we have a control system, which does the kind of cool high-level sailing logic, such as how to get from one place to another in a sort of optimal route, dealing with tacking code, so how to set up winds and sort of thing. So that's done using that's the middleware called Boat D, which started off as a joke. The system being Boat D. Thought it'd be funny, but it actually implemented, and it actually works okay. For some definitions, okay. So the code is split into two main parts. You have the driver, which deals with the how to do things on a particular boat, such as how to move a rudder to 45 degrees, or how to set sail to a particular angle, how to read in data from the sensors, and then that goes through Boat D, and that's accessed using a HB API, and a particular behavior can connect that and perform high-level logic. So your behavior can be swapped between different boats. Yeah, that's about it. And then another project that I've been working on particularly, but I like contributions from other people, is a simulator. Our current simulator is this Java thing, which the physics model is quite primitive. So we've been trying to build a new one, a successor to that, so we can use it to build a control system.
I'm pretty sure the old simulator was in fact a game that was hacked to be a simulator.
It was by Colin.
By Colin. So
10 years ago.
Yeah.
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 So that's not a project that we'd like more. Think about it. Anything else?
Not that I can think of.
So Bob is. Do you want to talk about Bob's one?
Sure.
So Bob is using an Arduino and isn't really fancy architecture like that. Just a bunch of hardware and drivers for that cobbled together. And hopefully we'll get that improved this year to something much better. That's really all there is to say about Bob's code right now.
Yeah,
It's messy.
barely existing.
So we're looking for people. And this is sort of skills and stuff that needs to be done this year. So we like people who can write software and design electronics and maybe even do some labor architecture. We especially want people who might be able to help with sponsorship and do some multimedia stuff. However, you don't need to have these skills to come into it. If you're willing to learn these skills, then that's great. That's perfect, exactly what we want. So if you're interested, you should come see us. And I think that's it.
Yeah.
So does anyone have any questions?
If there are any questions, sorry.
Any questions?
Kieran, do you want to start?
That sounds like no.
Excellent.
Yeah, well, thank you.
So next up we have Kieran, who's going to talk about some of the work he did over summer on the neural network.
Yes. Can you all hear me? No. I'm going to sit there. Can you all hear me now? No. I'm probably now. Hello? Right, so basically this is a shortened version of a presentation I gave whilst I was at Couse this summer. A little bit of a thing. If anybody wants to go there for a studentship for 4 to 6 months, come see me afterwards. I'll drop you an email. Give me your email and I'll drop an email off to my supervisor. This is just really an output for that presentation anyway. So in the media recently, there's been a lot about deep learning, and when I went to Couse, people often ask me like basically what it was, because this is what I did my dissertation in, this is what I do now, and this is what I did then, kind of thing. So I think to basically clear all things up about this, I think it's best to give a presentation. This doesn't work.
It might be you're not limited to
That's actually pointing.
No, it's clicked on the wrong window, isn't it?
Yeah, it is. Just click on the star. Okay, so I'm clicking on the one that
Neil needs to do it.
and then the thing will start working.
and then it should work. Can you try that?
Yes. Okay. So deep learning is a subset of artificial intelligence. Of machine learning, which of course is a subset of artificial intelligence. All AI is basically a set of algorithms that optimize themselves. That's literally the most rudimentary way of describing what it is. And another rudimentary form to basically describe things is pattern recognition. That's all deep learning does. It's a way of machines to classify what they perceive. That's it. I know. So it doesn't work at all. Okay. So you probably heard this word, artificial neural networks. There's a lot about it in the media at the moment. Companies like Google and IBM, etc., are investing a lot of money into this. So these are basic mathematical models that make stochastic decisions. That's all they do inside. They try to mirror the functionality of the human brain. This is why they refer to as neural networks. In the brain, we have billions and billions of neurons, which learn eventually to recognize, patterns or phenomena such as what a face looks like, what text looks like, etc. These models have names such as restricted Boltzmann machines, deep belief networks, or convolutional neural networks. These are the most widely used at the moment for most image recognition tasks. But over the summer, I use these for some. Does anybody here know about genome sequencing, etc., pathway finding? No. Anyway, so it's basically a text input. What are you going to say next? Yeah. So what can deep learning do?
So basically, anything that we can bring down into numeric formats, into vectors, is fair game, basically. If we can find patterns in it, then deep learning can obviously do something with it. So this could be things such as digital media, which is anything that we see all year: text, audio, video, etc., images. Sensor output, whether it's from, this is another thing which is currently being done at COUS. They're using artificial neural networks in order to do things from readings, from sensors, etc., from readings from this, instead of using event-driven programming, because anybody who's done that knows how bad it can be. And another thing which a lot of investment has gone into is time series data. So basically things like stock markets, housing prices, etc., etc. Next. So what we can do as, basically students, pretty much any machine learning task can be replaced with deep learning. Google and Microsoft right now, at this very moment, are trying deep learning to better, build a recommendation engine. So they're trying to develop a new Google search engine based entirely on what people have searched for before. So it'll give us, so at the moment it does it using some kind of a PageRank algorithm in order to give what, so when you type in that, it'll give you lots of things. So that's all done by PageRank. But wouldn't it be better if it was personalized? So it'd be able to take our data and build a more personalized experience. It also has a very, 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 very big impact, or potential impact in the field of medicine, such as anomaly detection, which is things such as X-rays, which is what I did my dissertation on, or any kind of readings from blood, etc. Because doctors tend to be quite busy and expensive. So if we can reduce the time spent on just looking at readings, X-rays, etc., this would be great. And obviously much more, but it's too much to fit on this one slide. Okay. So what makes deep learning so different to most machine learning algorithms? So it's all to do with basically features. Anyone who's done some machine learning previously knows that they have to do some sort of feature extraction in order to get a decent reading. With deep learning, you don't have to do this. All feature vectors are just what makes one thing different to another. So what makes it, that implicit detail, what makes it different. So for example, like what makes a computer different to a chair? I know that sounds easy, but for a computer, it can't do this without some form of feature extraction. So over the summer, I worked on plant images, and even the smallest, the tiniest differences could basically be the biggest biological differences within that data. So all this deep learning does is make an automated process. That's it. That's the thing to take away from this. So it does this by comparing through training. So MINIST is a data set comprised of 60,000 number images. And if you look here, so this is quite obviously number one. This is a feature vector for the number one. It's the thing that makes it explicitly that number, this being number 8, etc. So it can kind of denote what number it is using this feature vector kind of thing. So a lot of people also don't understand the difference between deep learning and shallow learning. At COUS especially, a lot of people, because they knew machine learning previously, and they knew deep learning previously, or artificial neural networks, they didn't know anything about what deep learning really was. All it literally is that this is a neural network. This is basically the input, so it could be an image, whatever, some kind of numeric representation of data. These are your hidden layers. And if you look, this is a shallow neural network. All it contains is a single layer, whereas this contains multiple hidden layers. This is literally the only difference. This has been around since the 1960s. But to train something like this, you needed a lot of computational power, and only recently has this actually been allowed. Basically, we can actually do this because computers are finally fast enough to do this kind of, large-scale deep learning. So I think it's important to actually say like what we can do with it instead of just saying this is it kind of thing. So over the summer, this was the first project I worked on, which was fine-grained classification. So anyone who worked with like computer vision knows that fine-grained classification is a massive, difficult problem. It's incredibly hard to do. It has to do tons and tons of pre-processing. With my data set, even the smallest visual database, such as the stem and styles, etc., size, etc., was a huge biological difference within the plant data set. This obviously is a huge problem for most things. You can even bring this down into text classification, etc. So as I said just then, it usually requires a lot of pre-processing. And even then, it's still difficult for us human beings to actually do this ourselves without basically training as a botanist, etc. So to do this, I created it's a form of neural network called a convolutional neural network. It's a form of restricted Boltzmann machine, which again is just a simple on and off stochastic neural network in the hidden layers. The only difference is that it performs isometrically. So basically, in an RBM, a traditional RBM or a deep belief network, the hidden layers would attach together. All of them would attach together, every single one to another. With a convolutional neural network, they just attach to the first, the one on the left, the one on the right. That's it. But what this allows us to do is to learn data such as images, etc., in patches. So instead of basically giving it all the data at once and asking it to, extract the features from this, we're breaking it down into smaller and smaller, and then putting it back, trying to give an output then as an entire feature vector. So each piece is learned and then taken as a whole, for example. So we learn patches, and eventually the output would then be the complete image, or the feature within that image. So I worked at the Computational Bioscience Research at KAUST. We managed to get our hands on 17,000 in the wild images. So these aren't herbarium images. These are photographs taken with a camera outside. They were taken in West Africa and provided by Sept. I did want to put a few in here, but I wasn't allowed to put them in. I had the email yesterday, and they said you cannot put them in, unfortunately, not until the paper's been released. But they were fairly labeled. I say labeled. I had to do a lot of CSV passing, etc., in order to think. So we required to basically build a deep learning pipeline. And with a convolutional neural network, we exceed accuracies of around 84 to 99%, which is pretty high. I mean, like, we're able to classify effectively 5,000 images within 10 minutes. Basically say what the traits are, what species they are, what color they are, or how many the stamen number, etc., the length of the leaf, within 10 minutes. With obviously not amazing accuracy, but it's okay. It doesn't seem to. Another thing I worked on, this was just a side project, which was ended up being something different, was so my supervisor said to me that he has basically these long strings of text that he needs classified. He just said, you just do this for me. I didn't really get given like much of a say. He didn't say what he wanted specifically, just I want this to say this, this to say this. So this is basically a form of sentiment analysis. So neural networks are also capable of natural language processing. So sentiment analysis is basically saying whether something's positive or negative. So whether something is positive or negative. So whether it's an emotional tone, bias, and intensity. So this is obviously can be used many different. So basically, by using the Cornell IMDb sentiment analysis dataset, we were able to determine whether a review was positive or negative in tone using a convolutional neural network, which was most widely used for images. And we broke the record, not by much, by 4%. But we were able to actually prove that we could actually use something that wasn't non-practical in order to do it, in order to perform this task, even though traditionally we use something like a restricted Boltzmann machine, etc., to do this. We use the convolutional neural network. I think I'm about run out of time. So basically, deep learning is a simple form of machine learning. It learns like the human brain. There's no need for manual feature extraction. It saves time sometimes. It's super powerful. It's fairly easy to jump into. I would recommend Keras with PyVet. I should have put a link up. I apologize. Just Google it, it'll come up. That's it. Thank you for listening. Any questions?
Kieran, this is obviously software-based, isn't it?
Yeah, yes, of course.
Your idea of doing rodent brain, do you actually think the hardware, rodent brain?
Yes, okay, yes.
Do you think hardware applications
So it's all
realistic?
Well, you mean in terms of using neural networks in order to build hardware? Yeah, that's what IBM are trying to do. Yeah,
What I'm saying is, do you think that's realistic, or do you think it's in the stage of the realm of software like you're doing that?
Well, I don't know. I don't know anything about the hardware side, do I? Obviously.
That was a subject for a PhD here 20 years ago.
Yeah. Any other questions?
So next we have Dave Price talking about amateur radio.
Dave Price and Gang of Helpers.
No one else.
Hi, yeah.
Why not break that?
Okay, everyone. So over the last few years, we've attempted to run some amateur radio training during the year for people that are interested. So we thought we'd come along and just tell you a little bit about what we've been doing. Is this thing going to work? Oh, look at that. Okay, so what's it got to do with impact? So we're all in different departments, but we're all part of the Institute of Maths, Physics, Computer Science. So tiny bit about that. tiny bit about UK law, amateur radio, licenses, privileges, and then outside we've got some demos of very simple things we set up tonight. Okay, so what's physics got to do with it? Well, radio transmission is all about waves going through the ionosphere, moving around the world, and with the right frequencies and the right antennas, you can get from here to absolutely anywhere else on the globe with no equipment from an internet provider, no equipment from a telephone company or anything like that. You can make direct connections all around the world, as well as short things. So amateur radio operators are quite often interested in what's the atmosphere doing, because that will determine where they can talk to at any point in time. And physicists are actually used to, are quite interested in this, because they're interested in using the radio to find out what the atmosphere is doing the other way around. And up on the top of the hill here, over the road from Penlice Farm, we've got another research station on another farm the other side of the road, which has been used by our physics department for many, many years doing ionospheric research. And we've got access to part of the facilities there. Computing, lots of modern radios are essentially computer driven. Lots of modern radios are used linked to radio devices, computers and radio devices. So computing's involved. What maths got to do with this? Well, actually, ever such a lot of the clever techniques that have been put together over the last few years to allow data transmission will actually manage to do data transmission when you listen to the radio, you would say there's nothing there. But by analysing to what to us might just sound like noise, they manage to pick out signals over vast distances of many, many kilometres, even though it just sounds like noise. That's all about clever mathematical algorithms analysing what's actually there. So all of these things all have something to do with impacts and are all things to do with radio. So various things. Amateur radio is licensed in the UK. It's one of the few hobbies, if you like, where you've actually got to have a license to participate in the hobby. But once you've got that license, providing you sit within the frequencies and the powers that the government said we can do, you can essentially do anything you like. So you're not limited to just certain types of data transmission. You can do anything you like, providing you're not using it to run your commercial business. That's about the only thing you ban. Oh, you're not allowed to do nasty things like condemn religions and swear on the air and all that sort of stuff. But leaving that out, you can use it for anything you like, experimentation-wise. So you can use it just to talk to your friends on the far side of the world. You can use it to work out whether you can invent some new data transmission mode that allows you to transmit 10 gigabits in half a second. You won't do it, but you might. Okay, so anything you like, really. And then the other thing, the public service remark, certainly in this area, the local crowd of radio amateurs will help provide safety radio cover for lots and lots of events. We're helping with the Aberystwyth Triathlon on Sunday because, believe it or not, round here, mobile phones don't work in quite a lot of places. But with the amateur radio service, we managed to provide them with safety cover in conjunction with the local St John's ambulance. So non-technical training, experimentation, it's all about experimentation. They actually encourage you to do things that the radios can't do at the moment. All right, that's all exactly what we're allowed to do. Talking to your friends and, as I say, helping basically all these emergency services if needed, as well as local events. Why amateur radio? Well, the transmitters we use are much more capable than the sort of CB type transmitters. We're allowed to, in the UK, use up to 400 watts of power, which is really quite a lot. So you imagine what a 400 watt light bulb looks like. Well, okay, you can't see the radio waves, but it's that sort of amount of energy. If you're Italian, you'd be allowed about 10 kilowatts, but we're not Italian. So, and also community local users, this concept of repeaters, where you make a transmission, it's picked up by one radio, which then flips it onto another one. That's something that we're exploiting a little bit using the facility we've got at the farm. I keep saying non-commercial. Okay, so you've got to have a license. What have you got to get? Well, there's 3 levels of license in the UK, and this has made it really, really accessible to people. In other countries in the world, Ireland, for instance, there is, like there used to be in the UK, one giant complicated license, and you're not even allowed to press the button on the radio until you pass the lot. The UK, totally different. 3-level thing, foundation, intermediate, and full license. To get the foundation, you basically have to learn how to use the controls, learn the basis of the UK legislation, and operate safely. Don't damage yourself, don't injure others, don't interfere with other people. Very, very simple, and I think a 26-question multiple choice exam, if I remember rightly, which you can do in about half an hour, and really quite straightforward. There's then an intermediate license when you end up building electronics and perhaps invent your own radios or interfaces for your own radios, and then a full license, which is much more theoretical. But if you pass that, then you're allowed to operate at full power and you can supervise other people and lots of other things. Variants for clubs, extra privileges and whatever. So extra privileges. So one of the things that the Radio Society of Great Britain is trying to do is to promote radio as an interesting thing to people generally. So in December each year, they turn over the whole of December to a youngsters on the air, and their definition of youngsters is actually anybody less than 26 years old. So the vast majority of people in this room count. There's another side effect of that as well. People under 21 or people under 26 who are in full-time education can be completely free members of the Radio Society of Great Britain, which ends up getting you really quite interesting magazines, turning up with lots of technical articles and rights to vote at meetings and tons of stuff. Okay, quickly on. Right, so December this year then, December this year, Youngsters on the Air event again. Last year we did one day over in the foyer of Physical Sciences building. This year we're going to try and do three things. The local radio club has a meeting every Thursday night at an early point in the month. So that Thursday night is going to be a sort of show and tell, just radio, running up in Winevow Hall, deliberately aimed at people like yourselves and indeed teenagers and down to year nothing sort of thing. That will be on the Thursday night. On the Friday, the plan is to do something over in probably Physical Sciences building like we did again last year, again with people coming in and out. And then on the Saturday, if the weather holds, we're going to try and do a sort of outdoor event. The plan being that it's going to be a sort of radio treasure hunt. So that you hide radios around the places, people have radios and they try and hunt down where all the radios are hidden and all that sort of thing. So a sort of outdoor treasure hunt activity, but using radio to help find the treasure, if you like. Okay, we've got some equipment outside. Those of us that work for the university, if we do sort of work over and above our normal contracts, so for instance, you know, I've done work for the UK Janet Network for local county councils, teaching in Singapore and stuff like that. The university, the department allows us to decide how to spend a small amount of the money that comes from doing that work. This summer, rather than buying myself a new laptop and going off to conferences, I actually spent the vast majority of my share of the money deliberately buying 6 brand new radios so that we've got something for the whole institute for people to join in. So we bought about £3,000 of the radios deliberately to enable people to do things, all right? Whether that's just as a sort of hobby around our subject, or we'd be very keen on people doing final year projects. And we've got some ideas both on the science side and the computing side. So we've got computers, we've got radios, we've got antennas, and we've got a whole pile sitting outside. Colin, do you want to, have we got any time left?
What I was going to add, the event that we're planning, is that going? The event that we're planning at the end of the year is the last.
This is ironic, give the radio.
Is that working?
Yeah.
Right. The event that we plan, the Youngsters on the Air, at the end of the term is the very last weekend of term. So if you're planning to come to it, make sure you don't go home early. And we've also, I don't know if we've got time to demo anything we've got here.
Well, we'll demo things outside.
We've got a few radios, we've got a demo out there, come and talk to us and show you what's else.
And don't be put off by my money about the amount of money I spent. These things are £25 each. The big posh thing we got out there is 1,500 quid. So there is a wide range, but the little ones are quite affordable.
So thank you, Dave and Colin.
Okay, so yeah, you'll get some questions outside now. There should be pizzas and beers and soft drinks outside, down in the thick tank, a trendy name for what's a concourse. And there's some free t-shirts, there's some free bags that we've managed to scrounge. So help yourself to those. They're on a desk kind of at the far end. Free notes as well, apparently. I will send you
Not working.
Hello everyone, I'm Sawyer. I just got here from America a few days ago. This is a project I have been working on since my first year of college. I'm only a third year, so I finished this version about a year ago, so it only took about a year to build. But it's an app that you use for tennis coaches to track all your players and all your matches and tournaments and things like that from year to year. Oh, thank you. And so this originally was built for iOS, and I published it on the iOS App Store, I think last June. Eventually, there are updates I couldn't keep up. My Mac got updated, and I had to take it off the store because I couldn't afford to keep updating. So I switched to the Google Play Store. Now it's available on the Google Play Store if you want to check it out.
Can you press the button on the mic?
Is this good? There we go.
Yeah.
There we go. All right, so I just kind of wanted to show you guys what tennis really is. It's a little bit different in America, the way we do college tennis and things like that, so it might be a little bit confusing, but basically what it does is it uses a built-in database, so it's not dependent on anything at all. It just runs on its own. So you go here to manage your players, and I don't have anything in here because this is the first time I was running it on this machine. Usually it sits on your app, your device, and you keep your data from year to year on here. So you can add your players from here, and they start from year to year, and they will automatically move up in years, and it will calculate the wins, the losses, the percentages. And if I had someone in here, you could also click on their name, and you can view every person they've ever played, and you could see what the score was, and things like that, and other stats associated with it. And the benefit of this is, after the regular season, they will have conference tournaments, state tournaments, and things like that, where you play the same players you had played in regular season, kind of like with playoffs. And so it's really useful if you get matched up with someone again to see exactly how they played against them, so you can possibly go for different strategies. So when you have a large team and things like that, it makes it a lot easier on you as a coach. So that's the first part of it. Next, I'll show you the duels. So this is the screen that comes up. And I apologize if things are a little out of shape because it's not meant for a PC. So you would input your opponent and where it is, and then you fill in these boxes with your players. And then obviously you determine the winner and the score over here. And you just input it as you go as a coach, or you have your assistant coach do it or something like that. And then it tallies up your total wins and losses. You play either 5 singles and 3 doubles, or is it 6 singles and 3 doubles, or in high school it's a little bit different. I think you play 4 singles and 3 doubles. So it accommodates for all types of duels and leagues and things like that in the U.S. I'm just going to go ahead and go out of here. There's also challenge matches, just more like database functionality that you can track within your own team instead of keeping it in the duels. So separate that out. This is the coolest part. This is what separates it from any app that's on the store currently. We have this. It's called match charting. So I'm just going to go ahead and start a quick one here. And what it does is it's the exact details of every point in a match. So you can choose between service actions, returns, rallies, errors, and then just see the score. And what you do is you press one of these green buttons to add one, and you can put it anywhere on the map and give it a power level as well. And so throughout the match, you continually do this, and you can choose to like, because you switch sides when you play, you choose to move them all over here so you can kind of see where they're good at when they're hitting their forehands and backhands, things like that. And then you can filter out all the things that you put in here as you go along. And then you can also get a breakdown of all the things that you're playing as to get even more detailed statistics that way. You can do it for your opponent as well as your player here. And it accommodates all scoring sets and even pro sets for JV matches if you want. And you can look at all the things at any point in time. And it all saves within the app. So there's that. And then the last thing is something I had added at the end as a request of one of my coaches. it runs tournaments. I'm not going to run the tournament. It's kind of crazy because you have to input a lot of names and things like that. So basically, you sit at a table, and then all players that play, they come back and report your scores. And so then it pairs up the next players in the matches, and then it'll send them out to report for you. So you just have someone at the table running this. And I actually did run this app at a real tournament 2 times, I think, and it significantly sped up the, the getting out of matches and reporting of scores and things like that. And there was a lot of positive feedback from that, so that was pretty encouraging. I think that wraps about everything up. You guys have any questions for me?
You said before that you had to move this from iOS over to the Google Store.
Yes.
More for the benefit of some of the freshers here, what would you say was the biggest challenge that you had actually porting it over?
Well, I think the biggest challenge is getting things to be in the right spot. I mean, that was definitely the biggest challenge because on Android you have so many different devices, resolutions, and things like that. And with iOS, it's a lot simpler with just when we have iPhone, iPad, and a lot of them have the same resolutions. So I had to accommodate for all different kinds of inputs and things like that. And also, I had to make sure that it wouldn't be too small. So actually, I had to implement some different zooming features to make it easier for the user to press the buttons and things like that. So I had to spend a significant amount of time doing that.
Thanks.
Next up, we have a Lou talking
No. Sorry, I thought this is the fast my voice. So yes, now that we're talking sports, just carry on. So last year I was away in an industrial year. So while I was there on my weekend, I decided to make this up because I wanted to do some sports at my place of work, but the weather was so inconsistent and I just never knew if I should pack my boots or not. So I thought, well, I could just look at a widget or something, but I needed some more specific information. So the app basically uses weather parameters to answer a question like, is the weather tomorrow morning at 6 a.m. suitable for me to go for a run? So basically I want a certain time, a certain sport, and it to be tailored to me as well. So this currently supports about 10 major outdoor sports, tennis, football, running, netball, basketball, and some other sports. It's currently in Google Play. I'll just show you a video roughly of what it does. So the interface is simple. You put in, it captures your location. You could change the time and date, change the sports that you want. And just check the condition, and it gives you almost a zero, almost like a yes or no answer, but in terms of percentage, okay, this weather is probably good enough. And then it asks you, based on this weather, you would actually be playing. The purpose of that is because it actually learns the usage that you do. There's the training mode which can be activated or deactivated. So, and then you could obviously type the city yourself. So yeah, that's what it does. And for me personally, it was quite useful in terms of just using. So it's a Google Play, you can search for sporting weather with no space. So some of you might think, well, why not just use OK Google? Well, I tried and it just doesn't quite come up with the proper result. I think my interpretation of it is just basically Google is currently capable of learning if I'm the type of person that actually don't mind playing football when it's raining, but not when it's freezing cold. So you can't possibly suggest anything because it doesn't know what sort of user that I am, which is what the app looks to actually address, learn from you. So what's involved in it on the more well, it's an Android app, so it's Java programming, and it reads data from the free weather information data source. I used Open Weather Map. It's free and they provide a reasonably accurate and up-to-date information for up to 16 days. You could get information about weather every 30 minutes and hourly as well. There's as much as 200,000 cities, and you can get data in JSON or XML format. So after that, it relates that data with research average to make initial suggestions. So at the very start, so while I was developing this, I did some research to get suitable conditions for different sports. Okay, ideally for an average person, what sort of, because it looks at things like your wind speed, temperature, rain precipitation, humidity, looks at all these things to go on. And then I did a survey of about 50 people that does quite, they're quite sporty people. Then I did some data gathering as well. And then finally, I used the machine learning algorithm, which I didn't have here. I'm actually talking machine learning today. So it's perception, which actually improved. This was used to improve the suggestion that I gives. And the idea of it being, it captures perception, basically takes different binary inputs and returns one result. Well, it changes the weight. So when I say weight, it's almost like, okay, just at its most basic form, it's like, okay, this person, I just told this person not to do this sport because the weather is bad, but this person is saying, I'm going to do it anyway. What parameter in the weather condition was, the worst, and that kind of a thing. And then I just took the weight of that based on that, and it learns that way till it gets to a point where it can actually give a proper result. Yeah, that's it. Thanks for listening. Any questions?
So I think Louis is up next. Are you ready?
No. We swapped with the puzzlement before me.
Okay, apparently Louis is not up next. So we have Ariel.
Louis, is it working? Is you not put your laptop open? It's working with the slides on.
Okay. Okay, so my talk has got a fancy name. It's a simple concept. So building a digital picture frame for the 21st century. Thankfully, it's a simple concept, but it's got some gotchas along the way. By the way, I'm Ariel. I arrived as an international student 1 week ago, I think now. And well, I've built what is essentially a wooden frame housing a modified PC monitor with an embedded computer running a glorified slideshow screensaver, and it's got some bells and whistles. So this all started at maybe Christmas time last year when I went to find a gift for my mom for Christmas, and I thought picture frame, digital, had some nice images of me, her kids, other kids, and holiday photos and such. It would be a nice idea. And so the first time I sort of encountered these sorry about that. The first time I encountered these digital picture frames were probably back in 2005. And at that time, they were like 7 inches TN panels with the horrible viewing angles. So I naturally expected like at least to have that the field would have advanced a bit in like the 9 years since I first saw them. But when I got to the store, this is what met me. And at £45, it's not exactly a good deal. Still got the TM panel, still 7 inches at 480 by 234 pixels resolution. Not really happy about that. So I thought that's got to be a fluke. Someone's just trying to make money off of old stuff. So I went online, and lo and behold, I found the Rollei design line 6170. Says 1080p down here. That's not really the case though. As you can see, 1600 by 900 pixels is the actual resolution of the panel. It's 17.3 inches, and it's got a TFT LED display. Maybe a TN, maybe an IPS, who knows. So this was still not good enough for me. This is about 160 pounds, and at that price, I mean, okay, it can do movies, it can do photos and music and clocks. And it's got calendar, but still not really what I was after. So I thought, with these sort of drawbacks in mind, I needed to drop some requirements. Could I maybe make something myself? I had heard of other people doing similar things. So I thought requirements, well, at least full HD, large viewing angle panel, meaning IPS or PLS, and easy on the eyes. I wanted this to be almost like a design piece on my mom's living room wall. And so I wanted maybe like a wooden frame or something along those lines. I wanted to facilitate smooth fading between images, so the thing would just sort of blend in with the environment, not be cutting hard to the next image every couple of minutes. And it needed to be available over Wi-Fi. One thing I haven't mentioned is that these sort of digital picture frames usually use SD cards for sort of facilitating inputting new images and then managing your pool. And that's ancient. So I wanted to make it Wi-Fi-able. And it should be automated in the sense that it should just take care of stuff. To put images onto it, it should just take care of the rest. And I really want to be able to schedule it in the sense that I would like for this thing to be able to shut itself off during the night or whenever it's appropriate. Maybe even sort of connect that up to the Wi-Fi bit in the sense that maybe it could have like a schedule available as a service, a web service. Anyway. So naturally, I pulled into my bag of stuff, and I did a feasibility study and all that. No, I didn't. I challenged my inner Clarkson, and I thought to myself, how hard can it be? It's got to be simple, right? I mean, I've basically laid out all the components there. So I found a suitable donor monitor, if you will, 22-inch, appropriate size, at least according to my mom, and it's got a LED-backed PLS panel, meaning it's got about 176 degrees viewing angle, making it actually possible to view the image at, say, this angle that I'm standing on. Really nice stuff. And I took that apart. I got a wooden frame made or milled out by a specialist. Turned out the frame makers in my area don't want to tackle that stuff, so I had to sort of half make it myself from basically like an L-beam made out of wood. And I stuck a Raspberry Pi into the back of it, and yeah, sort of just glued and taped that thing together. So now I had a good sort of hardware solution, right? And the software, well, that was just going to be a script, right? It's always just like, we'll sort that out later. So if you look at the requirements again, we have a few things there to take care of, so some components. So I started out with the smooth fading part, or the noticeable blend. So my goal was to let the device transition between images without drawing attention to itself. It should just be a part of sort of the living room. So my strategy for this was to just facilitate letting an image stay on for any amount of minutes, then smoothly blend over to the next image over a period of whatever seconds. And well, the condition for this is to be able to actually render these transitional or composite images at an appropriate rate, meaning this is just a shorthand for anything that doesn't appear to be flickering for a human. So what actually turned out to be the case, though, was that this isn't really the Raspberry Pi's strongest suit out of the box. The thing is that most programs are not really written with the Raspberry Pi in mind. And from a Linux perspective, this thing, of course, runs Linux. So from a Linux perspective, it's like when you just do a search for anything that has like a slideshow feature in a program such as like a screensaver or whatever, the frame buffer image viewer or PQIV, you'll find that they have memory leaks that are mostly unnoticeable in like a normal desktop scenario. But when you're running 24/7 and you have a Raspberry Pi to work with, it can get out of hand. So I figured this was a problem in need of a specialized solution. So again, I gotta be honest with you, I cheated. Letting someone else handle the whole adaptable blender deal, much more easy than trying and do GPU programming on a Raspberry Pi. So I found a program that's called Infobeamer. That's actually originally an open source digital signage solution. But the authors made available a closed source version for Raspberry Pi that uses GPU acceleration. So the thing is that it's about $40 or so for one device license. If you want to use it at home, you'll have a little text saying Infobeamer appear every minute or so. I haven't bought the license since that's a reasonable thing to sort of deal with at a later time. So anyway, it has a Lua-based scripting language that basically facilitates all that randomization of image pool and transition delay and all of that easily managed through the scripting. But so we still have to get the images onto it. So I wanted my mom just to be able to sort of upload the images, preferably then via Samba. So of course on Linux we have Samba available to make available an SMB share, much like your M drive at school. So I made one of those sort of integrated. I mean, and in order for this to actually be successful, you need a wireless dongle that will not crash and burn. Mine does. And so my wireless dongle will sort of it will bug out every now and again. No one knows why, but I again took a shortcut. I bought a cheap one from China. Had I gone to SparkFun, I would have had to pay out more for like a suitable dongle, but I'm guessing I'm going to do that for sort of the when I return to my mom's place in the winter. Anyway, so part 2 of Wi-Fi is to facilitate basically remote login. So what I used here is just a SSH tunnel, reverse SSH tunnel. What that means, we'll come back to in a minute. What you need for this is either to have a remote server available, which I do, thankfully, or you need to start messing around with dynamic DNS, and in that case, you would also probably need to open up some ports, inbound ports on your end, not the Raspberry Pi end. So just an example here. This is systemd service descriptor. I'm using Arch Linux. Arch Linux has transitioned over to using systemd for service management and init, basically. So all this says is basically run this command. So this SSH command just specifies don't actually run anything on the remote server. And what you want to do is bind the remote, you want to bind the Raspberry Pi's port 22 SSH port to the remote server's lead port of 1337. And so long as you set that up also on your server end, you'll be good. Loads of tutorials on this. It's a really neat trick. What essentially happens is that my Raspberry Pi, when it boots up, it will log into my server in London. And so that's pretty much it for that part. I wanted also to sort of be able to glue this all together. We've got the Infobeamer part, we've got the SMB part, but it turns out Infobeamer really wants HD images, not megapixel war crazy images from your super camera. So I have to sort of have every component cooperate and run smoothly and handle edge cases. So Python scripts, systemd services to rescue. As just an example of the sort of script that I use to bring new images in from the Samba share into the the Infobeamer pool. What it does is just uses iNotify to check the Samba share, and when it gets any new images in, it downconverts them and synchronizes the directory structures. Basically, that means that if one image is removed from the Samba share, make sure to update the pool in the Infobeamer pool. Yeah. So also we have systemd service files, not only for sort of the SSH reverse tunnel and all that, but basically all of my utility programs, the glue programs, all these things, they also are run as services. So that lets the operating system manage the execution of your scripts, meaning that, for instance, boot order and dependencies and automatic restart on failure, all of these things that we took a look at earlier. I could say, for instance, with the SSH, I have that restart if it fails after 10 minutes. So if my initial connection times out, and it does when I boot up because of the dependency, the ordering isn't right at the moment. So when that fails, systemd will wait for 10 minutes and then just try again. So yeah, management of health, basically, of your services. So scheduling, this is the part where I sort of should have done my homework. This is an RTC, meaning a real-time clock. I wanted to allow this thing to power itself down and up again at any given sort of time. And so the natural way to go about that, just get a script to interface with the RTC. But yeah, I didn't think of the fact that the Raspberry Pi is an embedded computer that sacrifices a lot of features, such as the RTC, in order to just be credit card sized. So I didn't have this with me when I went down to the southern coast of Norway and started programming this thing. So I'll have to fix this come winter when I return home. So in conclusion, well, feature creep is one thing I've brushed over it a bit. The thing is that this project originally started just as like, I'll write a script and the hardware part will be the hard part. In the end, this is a DIY solution, so it's naturally expandable, and this will just like happen on its own, in the sense that, for instance, now I'm looking at like, maybe we should add video support, so I can maybe film myself and say, hello, mom, and just have that here on her living room wall. Motion sensors, well, maybe it should just wake itself from sleep upon activation of one of these. Natural enough, really. Maybe integrate with Google Drive, or for my mom, OneDrive, Dropbox, whatever, to have new images uploaded that way. That's actually what I'm thinking of checking out for the sole reason of being that my brother lives on Hawaii, and I think my mom really would like to see more images of him and would like for him to upload stuff. So maybe we'll facilitate that in the future. So what I've learned essentially is that building a device where someone else will be the end user means that there will be less room for cheating along the way. What I mean by that is that I couldn't just sort of go over to Aberystwyth and leave her with a half-done product. I had to actually complete this. And with that sort of challenge, that requirement, you have to really be mindful of a lot of the edge cases and a lot of things that you don't normally need to think of when you're just doing something for yourself. You could always just, if you're writing a script for yourself, you know that it doesn't handle UTF-8, but your mama doesn't know that, right? So it's a bit more challenging. So in the end, this is how it looks, running a slideshow, and this is my mom standing next to it, looking happy enough. I think it's a success so far. So yeah, that's my presentation. Thank you for listening. And, by the way, if you have any questions, we're short on time and all that, but do take contact with me. I'll be happy to discuss whatever, or yeah, help out in any way I can. Thank you very much.
If you could please fill in a feedback form for us, then we can put on more of these events if I hand them out to you all. And if you would like to give out your sticker to your favourite talker or shower, and then we'll give out the prize over in the think tank.
Okay, so basically there is a prize of a Raspberry Pi sitting in here, waiting for the best person you think who has shown or told something today. Okay, so take your sticker, and the robot guys have won it twice before. Every time. Okay. So maybe have enough Raspberry Pis. So give your sticker to the person or group that you thought did the best this evening, Could the speakers stand up so that people, just remind people who you are. Go on, Kieran, up you get. Who else is up? The Sailbot's up. Who else is? Ollie. And if they're gone, they're gone. Dave Price isn't standing up. He doesn't want a Raspberry Pi. Okay, so if you could do that, and then we'll move out from here and move into the other room, and you can chat to people again, and we'll give this out. Okay.
Just before you all go, this evening there is going to be an ABBA comp site social, and this happens pretty much every Friday night. So we'll be at the Cambrian hopefully after this, if you all want to join us for a lovely evening. And if you don't know what that is, you can follow one of us three.